Therefore, alpha equals 0.0. They're both 9.
Then you go to question 1. It's just kind of using the formulas. It's not very difficult. If any of you wants to do quiz number 8, if you've done quiz 8, sorry, quiz 9, I mean, quiz 9. No, I forgot. If you've done quiz 9, you can give it to me.
My X1. So you can use on there. It's called break. Moving rest.
You guys done question 1? Oh, not yet. Now, which of these formulas you need to use for question 1, guys? Tell me. There are four formulas. This is the confidence interval for mu when sigma is known. This sigma is unknown. This is the confidence interval for sigma squared, and this is the confidence interval for p. Now, which one of these four you need to use for question 1?
First one.
Huh?
Is it the first one?
What? Come on, guys. Wait. What does the question say? The question says that. Does the question say that the variance is known? It says that the n equal to 81 Right, let me do this. It says question 1 says n equal to 81, x bar equal to 74.6, and it says s is equal to 11.3. Right? So based on this, which formula should you use? You should, because it doesn't say that the variance is known. It only gives you the value for s, the sample standard deviation. So you need to use the second formula, right? Okay, so now we want 100 times 1 minus alpha to be 90. We want the 90% confidence interval. So 1 minus alpha is 0.9, alpha is 0.1, alpha by 2 is 0.05, and 1 minus alpha by 2 is 0.95. So the formula we need to use is x bar minus t n minus 1, which is 80, 0.95, s is 11.3, divided by the square root of n, which is 9, okay, comma x bar plus t80, 0.95, 11.3 divided by 9. Do you see how I got this? Yeah, this is the second formula in the list I gave you. This is the list, right? This is the second formula, right? Now we need to read this guy here. This is where the table I gave you comes in handy. To read this, you got the table I gave in front of you. You should have a table, guys. It looks something like this. Can you see this table? This is the table for the t distribution, right? Yeah. And you're looking for 80, 0.95. So you should go down to 80, which is here. This is 80, guys. This row here corresponds to 80. And we are looking for 0.95, which is this one. Right? 0.95 is the second column, or the third column, I mean. So the value that you're looking for is 1.664. Yeah? So the answer is this, x bar, which is 74.6 minus 1.664 multiplied by 11.3 divided by 9, comma 74.6 plus okay, so that's the answer. I mean, if you have a calculator, you can work this out, but I'm not gonna. Can you do question 2, please? No, question 2. Yeah, this is clear to all of you guys right now. So you just have to read the question and see which of the 4 formulas is relevant. Yeah? It's not really difficult. Can you do question 2, please? So I'll put the formula sheet back on, right? So you can see. Because sample standard deviation is S, not sigma. Sigma is the population standard deviation. S is the sample standard deviation.
Yeah, that's what I mean.
The sigma is the population one. Yeah. Yeah. Yes, okay.
Okay, so what is this from?
Do you guys follow how I did question one? Do you have any questions?
Somebody did
Question two, please. Oh, you said, okay. Like in the second question, you will see like by reading you should be able to figure out which formula to use.
So variance is given by 83,006 minus what I found before. Oh, there, yeah. How can we access the training? You were just too excited. You wanted to play. What games did you get anyway? Mate, I like you, Lucas. I won't see you for another 2 weeks. And then what you do during the Easter break, right? I don't know if it's right. I'm just saying. I am just saying. I do not know. Okay, so plot A, plot I. We know that sigma squared, which is the variance.
Remember guys, the sample standard deviation means S, right? And the population standard deviation is sigma. You should know the distinction between the two,
so we know
right?
sigma
Okay.
is root over E. So it really equals the
Alright, let's see how we can do question. We're done question one. Now question two, guys.
Okay, cool. I know what you're going to do.
Question two is you're told that n equal to 30 and sum of xi is this, and you're also told that the sum of xi is squared. Well, the first part is obvious, right? Because you're asking for confidence interval for mu when sigma squared is 30. So you know which formula to use, right? The first one, right? So it will be x bar minus z. You need to figure out 1 minus alpha by 2, which is for 95%. What? Okay, let me do that first. Okay, let me do that. For 95% means 100 times 1 minus alpha is 0.95, right? That's what it means. So 1 minus alpha is, sorry, 1 minus alpha is this. So alpha is 0.05. Alpha by 2 will be 0.025. And 1 minus alpha by 2 will be 0.975. Alright, so using this, you can figure out the confidence interval, which is sigma, which is 30 divided by the square root of, so sigma is square root of 30. Okay, so this is the confidence interval, right? Now to read this, guys, you need to go back to the table. There's a table I gave you for the z distribution, but I mean z is this one here. You should look at this table. To read 0.975, what you need to look for is, can you see 0.975 inside the table somewhere? Where is it? 0.975. Here you are. Can you see it? 0.975. And this corresponds to 1.9 and 0.06. Right? So the value of this is 1.96. Right? So what you have is this. This is equal to x bar minus 1.96 comma x bar plus 1.96. Do you see how I got it? Just reading the table, guys. You have the table in front of you, all of you. I gave it to you earlier. Yeah, so it's 1 point. Do you see how I got this? 1.96. Yes. Okay. So that's part one. Part two of the same question 2 is to find confidence interval for mu and sigma squared when sigma squared are unknown, or sigma squared is unknown. So the first is x bar minus t, n minus 1 is 29, comma 0.975. S, alright, S, I will come back to that in a minute. Then x bar plus t, 29, 0.975. S is sample standard deviation divided by. Alright. Now let's see how we can read this, guys. Now you should go back to the table for the t distribution. Can you look up the table for the t distribution? Right, with 29 comma 0.975. So it is this one. 29. This is the row 29. Okay, and you're looking for 0.975, which is this one here. Okay, so the value is this 2.044, 2.045. Okay, so this becomes x bar Alright? Now S, to compute S, you need to use the formula. I think it's a formula I gave you a long time ago. Even I don't remember the formula exactly by heart. But if you look in the notes somewhere, you will see the formula. There is a formula for S, which is given by the following, which is this is if you look back in the notes somewhere, you will see this is a formula for S, for sample variance, so sample standard deviation, right? And given the values for given these three information, you can compute this using a calculator and figure out what S is. Okay. Yeah. All right, and so that completes what doesn't exactly complete part 2, but the part 2 is also asking you to derive. The part 2 is also asking you to derive a confidence interval for sigma squared, which is, I just showed you the CI for sigma squared is this one. N minus 1, which is 29, comma 1 minus alpha by 2, which is 0.975, yeah, comma right. This is the formula for the confidence interval for the sigma squared. Right. Okay, we did this a couple of weeks ago, you may recall. Now you need to read these two percentiles. For that, you need to go back to the table I gave you at the beginning. So you should go back to the table for the chi-square distribution. It should be in front of you guys. The chi-square distribution. Right, this is the table for the chi-square distribution. So if you go down to 29, this is row 29. Okay. Okay, and from this you can read. 0.025, which is this one, and 0.975, which is this one. Okay, so these are the values we need. Right, so this becomes right, so that completes question 2. Do you see how I got these numbers, guys? It's from the table. If you look at this table here, right? The 0.025 is this number here, and 0.975 is this number. So I got this and this. Right. If this is clear, can you do the next question, please? Question 3.
feed is probability.
Can you all sign the attendance sheet? If anybody doesn't sign.
So can you put the formulas back on, please?
This is the formula sheet, and you need the one for the proportion, is it? This one, yeah. This is the. Anybody who hasn't signed yet, sign attendance sheet.
What's the next one? That's the only question.
Sign.
That's not it. It's 0.16. That's not.
Alright, for question 3, you need to use the last formula here, which is the formula for the proportion, right? That's for question 3. Remember, P stands for proportion.
It's a bomb. Like that. No. If I write something and put a dash at the end of it, it's a dash. If I put it above it, it's a dash. No. Like, if I write something and I write dash another word, that's a dash. If I write something and write dash above it, that's a bomb. Either way, we don't know what it is. Is it 80?
Okay.
Is it 80? The TV being filmed has no relevance. Yeah, no relevance, trust me. Yeah, so just what is next one? It's 80. No, it can't be. Because if you're looking at the formula, it says square root 1 minus x bar, and if x bar is 80, then it will be negative, it can't be squared.
Maybe anything.
It's not because x bar. I think it's 0.67. 1 6.
Yeah. 1 6 actually.
No.
1 6.
No, 0.16. So you
How
make
did you get that?
80 divided by 20.
Must be.
Actually, no. Actually, yeah, it must be.
It's not the number.
Yeah, because it's x bar for proportion. Yeah, you do.
That's proportion.
Sure, what's happening? Alpha is 0.1. And we actually get officially 0. So 9 is going to go. But n is hysterically large. N is a bit aggressive. N. At 0.16 times 0.84. Yeah. We just have to represent value. You know, it's actually quite
You guys done question 3, guys? You done? It's not difficult.
What is that?
0.9.
Yes.
I know, but it's alpha over 2.
Alright, let's take this out. So, question 3. You're asked for the. Let's see what you want to know. you're asked for the random sample. You have 500 households. 80 of them have 3 or more TV sets, right? So your N is 500. Your N is 500. And remember, in this case, X bar is the proportion, sample proportion. P is the population proportion. X bar is the sample proportion. Now, what would that be here? You're looking for the proportion of people who have 3 or more TV. What's that?
0.16.
It would be 80 divided by 500, right? Okay, which is 8 divided by 50 or 4 divided by 25. Okay, and we want a confidence interval, 90% confidence interval. So your 100 times 1 minus alpha is 0.9. So your 1 minus alpha is, sorry, what am I saying? Is 90, I mean 90. 1 minus alpha is 0.9, alpha is 0.1, alpha by 2 is 0.05, and 1 minus alpha by 2 is 0.95. Okay, so the formula that you need to use is the last one, which is X bar, which is 4 by 25, minus Z, 0.95, multiplied by X bar, which is okay, comma 4 over 25 plus Z 0.95 okay. So this is the confidence interval. Alright, now you need to read the Z, so you should go to the Z table. There you are. This is the table. Now you need to look for 0.95 in this table. There is no exactly, alright, this is exactly halfway between these 2 points. So this is 0.9495. This is 0.9505. So this is halfway between these two, right? So what you should do is it's 1.6, and then you have 0.04 and 0.05. So halfway between these two is 0.45. So your answer is is 1.645. Do you see how I got this? Mm-hmm. Yeah? Because it's halfway between 1.64 and 1.65, which is 1.645. Okay? Alright, can you do the next question, please? Question 4 now. Question 4. Just do only the first part, you can ignore the remaining. Question. Okay, guys. Just do the first part only for question 4. Do you have the just say the version? This one here. This tries this is another language. Remember that 2 songs will complete English. We don't have to know. Looking at that. I'll put the formula sheet back on. So this is the formula sheet to do question 4.
Because there was sunny burning and sleep, and someone like was cleaning or stuff, and was present. You don't fuck around.
We do not dance. I just try to see.
Heavy switch. You will play. I wouldn't know, just play switch. But I've got a book, like switch, book, switch. I've got a book and like 120 pieces of ability. I would think that switch one was free. How do I?
Has anybody done quiz 9, please? If you have quiz 9 with you, could you give it to me, please?
And I've actually tried. It's very well. I can't write my brain. What is the rest of the things out of the brain?
Just only do part 1, okay? It's not difficult, guys. It's you have a random sample where sigma squared is known. So what is the confidence interval? What's the confidence interval for me? It's this one, right? Okay, so all you have to do is just write down the confidence interval. So this is question 4. Okay, write down this confidence interval. Now it's asking you what is the width. What is the width of this confidence interval? Can somebody tell me? The width of this confidence interval is equal to 2 times z or z. Right, this is the width. Now the question is which variable quantities affect this width? It's kind of obvious, right? It affects. Now there are only 3 variables that affect the width. One is sigma. Right, sigma. As sigma increases, width increases too. Right? I mean, so the width is an increasing function of sigma, right? Clearly. The other variable that affects is n. As n increases, the width will decrease because this thing is a decreasing function of n, right? Okay. And the other variable that affects is alpha. As alpha increases, what do you think will happen to the width if alpha increases? Will it increase or decrease? The width will decrease as alpha increases. So that's all you have to do. Question 4. Right, can you do question 5 please now? Question 5. This is clear to all of you guys. Question 5 please.
Confidence, you have confidence that that's the 1 minus 0.975.
You done question 5, guys. Just do the first part. You don't need to do the second part. Same.
So n equals 96.
Right.
Sorry, give me the number for this.
So question 5. The question 5, part 1. I will only do part 1. Part 2 is similar. So you have sigma equal to 0.05. Your 100 times 1 minus alpha is 95, so that means 1 minus alpha is 0.95, alpha is 0.05, alpha by 2 is 0.025, and 1 minus alpha by 2 is 0.975. And we know that Z, we already worked this out. I think it was 1.96. Is that right? Was it 1.96?
Yes.
Okay. So the width is equal to 2 multiplied by 1.96 multiplied by sigma, which is 0.05, divided by the square root of n. Right? And we want this to be not exceed, that means it must be less than or equal to 0.02. Okay. So the question is to solve this equation for n, which is easy. This implies that root of n must be greater than or equal to 2 times 1.96 times 0.05 divided by 0.02. So this would be, n would be greater than or equal to 1.96 times 5 squared. Okay, that's it. That's the answer. You can work it out. Okay, that's question 5. Question. Can you try question 6 when you have time? Okay.
Right.
Question 6. Is this clear to all of you or not?
Right, we got it.
Yes.
Right.
Your question.
So question. So n equals 96.
So you can.
Cool.
Yeah, are you guys okay with this? See you later, guys. If you have any questions on the art coursework, just email me 24/7, okay? Or Zoom me 24/7. Okay?
I would use.
I'll see you next week, guys. Otherwise,
Like teach the behavior. It's like.
I think I'm gonna like try to get my all knowledge from this.
Like everything shooting and just like don't need to like look up all the kind of functions like that.
Okay. And where'd you get that from?
Like I use Haskell, which is like better and user friendly, more user friendly. And I can like set it on the website. They like do everything from normal R like.
Can I download all my computer?
Yes, for free. Like as such, like you need to download 500 the connection review, and with that you
Oh,
get
the one that you used there.
I would like it's the same thing, you know.
Is that the same thing?
It's literally the same thing.
Download and I'll try to do something someday.
But ours could be like better than Math.
see you guys.
Ours like basically like Python. The only thing I don't get is like why you can't use why like the equality
does that, like by the brush physically. You can use it as well, but nobody does that. Yeah, that's good. I'm not
See you guys later.
We got an answer, right? Any questions about the course, just feel free to email, okay? Sorry. And the same to your friend. Right.